Hello, my name's Andreas and I'm about to design and to build a boat. And when I say design, I mean I literally start with a blank piece of paper. So there will be some drawings, there will be some calculations, and of course there will be some models, like this one for example. And of course there will be a lot of experiments, because the one thing that I want to avoid is to sink my boat on its maiden voyage. Now, although I'm going to design a very specific kind of boat, which will be a sailboat, I think the design process is always the same, regardless of whether you build a motorboat, a speedboat, or a sailboat, maybe not a submergible. So I hope whatever you have in mind, there will be some useful hints for you in these videos. And let me know in the comment section what you are going to build. So that's it for now. Let's jump right in. That's better. Now the first step, of course, is to decide what kind of boat you want to build, and then you go out and look for the already existing designs which are close to the one that you want to do. The reason for that is that you can save a lot of guesswork. For example, how much weight will the new boat have, or how will it perform? What sail plan does it need? All these things you can avoid by modeling close to an existing one. That's not stealing or just copying. You will draw your own lines. It will be a totally new boat. It's just good design practice. However, when I tried to do this, I hit kind of a reef, because the one boat that I have in mind is not really there yet. Now, what do I want to do? I want basically a crossover between this weekend sailor. This is an example of the Balboa 16. And a pilot cutter, which is this beauty here. So I know that you can't see it very well in this angle, so I will show you them in detail. I start with the Balboa 16. What I like about this boat, first and foremost, is its size, because it's a 16-footer, so it's a small boat. And I like small boats because I'm on a budget, and so that suits me fine. It also has a rather easy sail plan, just the mainsail and Genoa, and that's just what I like. Also, despite the fact that it is a small vessel, it has a cabin, and I like that very well. If we look at the decks plan, what we see here is that this rather small vessel has really a lot of room to offer, and that is what I really like about this vessel. Basically, if you look at what you can do here, you have a cockpit, you have room spare to put 2 beds in. So this is really nice. And I actually want to go even a little further than that. I probably will build a boat that is even a little wider than that. Another design feature that I can show you here while we have this plan on close-up is the position of the main station. Now the main station I get when I cut the boat crosswise where it is the widest. And that will give me the main station. And as you can see here, the main station is not positioned in the middle of the ship, but a little towards aft, so to the back door of the ship. And that is what most modern sailing yachts offering these days. So they're a little bit like a wedge, really, that has its widest space a little bit aft of the midsection. I also like how the curve runs here. So that is called the shear line, which is basically the top line viewed either from the top or from the side. And as you can see, for example, on the other plan, here the shear line would be the top line that runs around here, and it's a rather gentle curve. Now, what do I not like about this boat is the underwater section. There's just not a lot of it there. It makes for a faster boat. That is nice. On the other hand, such a hull will, when hit by a wave, follow the wave rather strictly. And this is something that I don't really prefer. And so I am looking at the second boat right now, which is the aforementioned pilot cutter. The thing that we can see here is that if we compare them directly, we see that the pilot cutter is actually, when it comes to its hull, mostly underwater. So more than 60% of the hull, when we look at the height of the hull, is submerged. Whereas in this boat, it's quite the opposite. Most of it is above the waterline. So, and this is why I want to have a crossover between these two. I want the long keel, I want the huge underwater ship. And now you can say, well, isn't it a little bit crazy? I mean, basically you put brakes on your boat. Well, that's correct. On the other hand, small vessels of 16 foot are never fast that way. They're not really runners. And what I want to do, I want to build an extra safety feature here. I want the boat to react more sluggish to a wave. So when it is hit by a wave, I don't want it to follow it right away with the chance to capsize eventually. So this is why I want the long keel from this vessel, but a lot of design features from that vessel as well. Now, something else that I really like about this boat is the shear line, which is a little bit lifted towards the stern as well as to the stem. That is a very nice feature. And I also like kind of that this is a little bit rounded here. Maybe it's a touch too much, but I will discuss this in detail later. All right, so now you have seen the two boats, which I will now somewhat merge into one. I will create something like a virtual boat, and with this I can then make my own design. Now, why is this so important for me to have this long keel? Well, the answer lies within this book. It's called Seaworthiness, the Forgotten Factor, and is written by Professor Marchai. I don't know whether I pronounced the name right. Basically what he figured out is that the best way to make a boat safe and seaworthy is to put a long keel underneath it. I know there's a growing community saying otherwise, that the fin keel is the better solution. And most boats today, most modern sailing yachts are built with a fin keel. But the thing is, the philosophy behind it is basically that with a fin keel, you have a faster boat and you can just outrun whatever danger comes your way. Well, I want to build a small boat, and a small boat can't run that fast. So running is not an option. So I need something that can withstand a little roughness in the seaways. And therefore, I really prefer the long keel. By the way, I'm not going to go into more detail about this book, sorry. If you're interested, just let me know in the comments and I will put up a video and review this book in more detail. All right, now what I need is a plan. I need some reference from which I can start, and I have to get a little creative. So basically, what I need to do is I need somewhat to merge these two plans and make something like a virtual boat that I just can take as a reference to look at, and from there to make up my own design. So I did this on the computer. Let me show you how I did that. Okay, here we have the lines plan of that pilot cutter I've mentioned before. Before I start messing around with it, just a couple of things. First of all, if you are new to a lines plan and what it all means, don't you worry a thing. I will explain every single line when I start drawing. Right now, I'm really only interested in the upper part, so in the upper plan here. And in this plan, I'm only interested in two things. First, the outline in the profile view. That's the one thing that I'm interested in. And the other thing is, how will the boat look from the front or from the back. So basically the outline of this plan. That's all I want to have here. And I just want to get a visual. That's all that I want to do. Second thing I want to mention is this is actually not any old pilot cutter. These are the lines plans for the Tally-Ho project. So if you haven't heard of it yet, you should definitely check it out on YouTube. I will put a link in the description below. Leo is the boat builder and wizard who is actually on a mission to restore and to rebuild this about 108-year-old pilot cutter and to sail it later. So it's an amazing project. You can learn a lot from this guy, so definitely check it out. Now, the last thing that I want to say is, do I really need to do this step? And the answer is yes and no. No, because I have seen hundreds of lines plans and I feel confident enough just to sit on the drawing board, just draw some lines, and I will probably come up with something that gives me an idea of how the boat will look later. And yes, because this is really a quick way to give me a visual aid, which I can then tamper with. I can talk about some key features. So bottom line, I just admitted that I'm a little lazy. Now the truth is out and let's move on. First, I need to know the actual current size of the boat. So let's have a look at the image menu, resize, resample. There it is. Top corner, 1024 by 634. Very good. Unfortunately, this menu doesn't give me the numbers in inches or centimeters. For that, I take a peek into the print menu, and here on the bottom right corner are the numbers, but there's a little trap. As you can see, the preview has cut off part of the boat, so that's not correct. Oh, wait. Switching to landscape, and now everything is ship shape. Brilliant. Now, and here are the numbers, and I'm more used to the metric system, so I will use the 27.2 centimeters. Right, next step is to find out the ratio between the pixels and the centimeters or millimeters. I prefer millimeters, so I don't have a decimal point here. So it's how many pixels are there in a millimeter. So 1024 pixels per 272 millimeters makes 3.7647 and a lot more pixels per millimeter. Okay, I put this into the memory. And now the next step is to find the current length of the hull. So by dragging a frame, I hold the left mouse button and drag a frame, and then I adjust it a little bit. I can, yeah, that looks good. I can find the current length of the hull in pixels, of course. And in case you're wondering, why didn't I include the rudder? Length over all doesn't really mean length over everything. So if you have a bowsprit or a rudder or something else hanging from the hull and overlapping the hull lengthwise, it's not included in the overall length. The overall length is just the hull from end to end. Right, so how many pixels are there? It's an even 900. And that translates into 239 millimeters. Right. Now, the next thing is to compare this number to the desired, the new length of the boat in the plan. Now, I want the boat to be 160 millimeters in length. Why? Because that's just a nice number, because that gives me a ratio between the plan and the boat of 1 to 30. That sounds like an even number. If you prefer 1 to 25, 1 to 20, whatever floats your boat really, just make sure that the plan later will fit on a piece of paper. That's all. Right, we have 160 divided by 239. So this is the ratio between the new size, the new length of the hull and the old length of the hull. All I need to do is multiply this number with the current width of the picture, and I'm finally where I want to be. So let's do that. Okay, 685.5. So let's make it an even 686. That is the new size of the picture in pixels. resize, and here I type in 686. So one thing is very important, if you haven't started already and unchecked it, you need to make sure that you uncheck preserve aspect ratio. Otherwise the height would be changed with the width, and we don't want that. Okay, whoops. Now this is more like it. This is almost what I want. Good. The next step is to do the same steps with the height. And the height of the boat is a little bit more complicated because basically it is, well, given the shape, it can vary quite often through the length of the hull. So what I'm going to do is I will be playing with the draft. And the draft is the distance between the waterline and the bottom of the keel. And the waterline is the line up to which the boat is submerged into water. So that is a fixed distance. Let's see that I get this a little better. Maybe I just scale it up a bit. There you go. Yeah, that looks fantastic. So this is the waterline, this is the bottom of the keel, and I measure 134 pixels. How many millimeters? 134 divided by the ratio makes 35 point something millimeters. Again, it doesn't have to be exact. It's just a visual aid, and if it is a little bit out of proportion, that is really of no concern. Actually, I could almost leave it as it is right now, but just for the heck, you know, let's take, I want to have the draft of a meter, roughly a meter, so 3 foot 4 inches. And that's just, you know, arbitrary. It's just what I fancy right now. Basically, what I want is I want the hull to be deep enough so that I maybe can build a cabin which maybe allows me to maybe stay upright. But there's a lot of maybe, you know. I counted 3 maybes here. So I know, I just try. So a draft of 1 meter it is. And that means for the plan 33.333 millimeters. So let's do that, divided by what we found, 35.3. There you go. So we have a ratio of roughly 94%. And the actual height of the picture is 634 pixels. So the new height of the picture should be 598.6, or make it an even 599. Right. Resize 599, and there we go. Now the profile view of the boat is in the right proportions, in the right dimensions that I have in mind for my own boat. This is what it would look like from the side. The one thing that is now utterly incorrect is the station plan here in the middle. Although it has the right height, it doesn't really have the right width. It can't be, because this plan is actually 90 degrees to the other plan, so that wouldn't be working. So what I have to do now is I have to save the picture here. So I will just save it as something. There you go. Then I can continue and just alter the width of the plan once more, of the picture once more, just to get a correct plan of the stations. So the view from the front or aft. Let's blow this up a little bit. Yeah, that looks better. Again, it doesn't have to be perfect. Yeah, that looks about right, and I get 163 pixels, again translated into millimeters, gives me 43 point something, let's make it 43. Now I want the boat later to be of a beam of 8 foot, 2 meters and 40 centimeters. That would translate into 80 millimeters in the plan, so the new beam is 80 mil divided by the current beam, which is 43 point, let's make it 3. So this is the ratio, and now I have to take the current width of the picture times that ratio, and 1686. There you go. So 1267 pixels should be the new size of the width of the picture. 1267. Okay. Wow. Now that is a spacious boat. Let me tell you that. So let me drag a frame because I'm only interested in this part of the plan right now. And I will crop the selection. Okay, and here I have my station plan. And as I said, I'm only interested in the outline anyway, just to study it and to temper around with it a little bit. I will do this in the next part of the video. All right, now that you have seen how I managed to create kind of a virtual boat, I will show you what I'm going to do with the results. I have printed out the plan that I have modeled on the computer, and you will see it in detail and close up in a minute. Of course, as I've already explained, the plan here in the middle on the top is not really correct when I compress the boat lengthwise, so I had to make this small piece in its right dimensions, and I can now put these two together. Okay, so let's have a look at the close-up. All right, this is the virtual boat in detail. So it has a length of 16 foot, a beam, so a width of 8 foot, as can be seen here in the station plan, a draft of 3 foot 4 inches, which is a meter in metric. And so that's all very nice. Now, I want to discuss some features which I want to alter. First is the stem. The stem, for my taste, goes a little bit too far back. It always curves into the midship, and I don't really like that. So I probably will keep the curve, but I will probably end up here, something like that. So I will have a more strict curve coming up here, and that will be that. The other thing is that the keel lifts towards the end, and that's another feature that I don't really like. So I will probably keep the keel straight and let it meet with the stern post. Other than that, I think the main feature that I need to change a bit is the main station. Because if I build this like this, and having the compression that I used on this original plan, I don't really think that the body of this boat, the hull, would be submerged as it is drawn in the plan. So in order to make that happen again, I probably need the curve of the main station to be a little bit slimmer in the lower region. So I will probably go up furthermore, and then I will curve it in like here, and then I will go almost flat, and then I will come out. This is what I have in mind now. Okay, I think these are the features that I want to change. And other than that, I'm pretty happy with the results so far. So basically what I need to do now is draw some lines. So this, of course, will be the content of the next episode. So I hope you liked it so far. A thumbs up is always appreciated. And if you wanted to see more, then just subscribe and, of course, hit the little bell so that you are always up to date. Thanks for watching.